On the surface area of the shape created by revolving, pretty sure there's supposed to be 2x plus 3y equals 6, for negative 2 less than or equal to y less than 1 about the y axis. Okay, so this is a line, but it's not in the standard y-intercept form that we're used to. So first thing we're going to do is draw a picture, because that's pretty much what we always do first, unless there's no picture to be had, in which case we make do with a formula or some such to help get our visual mind in calibration. So the way I'm going to do this is, I know a line is just 2 points and you connect them. So I'm just going to find 2 points here for y negative 2. So 1, 2 to 1. And so we're going to have, if we plug in, let's say, negative 2 here for y. So we have, find out where it is on the x-axis. So 2x plus 3 times negative 2 equals 6. 2x minus 6 equals 6. 2x equals 12. X equals 6. 1, 2, 3, 4, 5, 6. So about here. And then we plug in 1. 2x plus 3 times 1 equals 6. 2x equals 3. X equals 3 over 2. So about here. And so we have a line from this point to this point, and we are going to revolve it around the y-axis. So we get something kind of like this. Maybe imagine like one of those little volcanoes that you make as a kid. Then you fill with baking soda and pour in vinegar. Okay, so here's our equation. And we are going to start by writing the equation for a surface area of a revolved shape. So we'll start with point 1, which is going to be negative 2. And we're going to go to point 2, which will be 1. We're going to do 2 pi r dl. So our L right here will be x. So, or r. So r will be our x value, and we want to integrate in the y direction because that's how we get this nice symmetry of the circle. And so we're going to have 2x plus 3y equals 6. X equals 6 minus 3y over 2, which equals, and I'm going to rewrite this as 3 minus 3 halves y equals 3 minus 3 halves y. There we go. So that is our x value, which is also our radius. Now we want to find dl. dl equals dx squared plus dy squared square rooted. Rearranging this, we get dx dy quantity squared plus 1 square rooted dy. Normally we factor out the delta x, but this time we're going to factor out the delta y because we want to integrate it in the y direction. So then our challenge is going to be, we want to find derivative of x with respect to y. So we have x equals 3 minus 3 halves y. Dx with respect to y equals negative 3 halves. Dx dy quantity squared will then be negative 9/4. Yep, I'm good with that. And so we can then rewrite our big equation as negative 2 to 1. Right up here. We'll factor out the 2 pi. We have our r, which is 3 minus 3 halves y. No parentheses there. And then we have negative 9/4 plus 1 square rooted. Okay, this one's not going to be too bad here because we can rewrite this 1 as 9 over 9. And then 9, oh no, we want to rewrite as 4 over 4, common denominator. Good catch. So then we're left with, oh. When you square something, the negative goes away. Good call. Good call. Okay. We still have a dy over here. Okay, so now we have 13 fourths. So, rewrite it again. Make it a little bit simpler. We have 2 pi. We have square root of 13 over square root of 4, which is just going to then be 2, which will cancel out with this 2 right here. And then I just took the constants and moved it out on the outside. 3 minus 3 halves y dy. This is a pretty easy integral to do. So we have square root of 13 pi times, we'll do 3y minus 3y squared over 2. But we already have a 2 there, so that will become a 4. This will be evaluated from 1 to negative 2 to 1. Put little parentheses there. And from this point, I think it's just algebra. Which, not to say that it's easy, it's just straightforward and prone to error. Okay, square root of 13 pi. Let's start with 1. So if we plug in 1 here, we have 3 times 1, which is 1, minus 3 over 4 times 1 squared, which is just minus 3/4. So we'll do it this way. There we go. Minus quantity, and we'll do the 2. So 3 times negative 2 is negative 6. Minus 3 times negative 2 squared, which is 3 times 4. So it'll be minus 3 times 4 over 4. The negative 2 part disappears because we squared a negative. So that kind of stays like that. So we got negative 6. Does it seem reasonable? It seems reasonable. I think we can do this. Confidence. Okay. It's one of those things like, am I going the right way? I don't know. Maybe. Possibly. Possibly not. Okay. So then negative 6 minus 3 is negative 9. It's a big negative. Okay. But then it becomes positive 9 with the double negative. And so we have here 2 1/4. So we could probably write this in terms of fourths. Maybe we should do this in terms of fourths. So if we multiply 3 by 4, we have 12. So this would be 12 fourths. 12 minus 3 is 9. So we have 9 fourths plus 9. 9 in fourths is in terms of 36. So 36 over 4. This looks suspiciously round. Nope, no it doesn't. Okay. So 9 plus 36 is 45 over 4 times square root of 13 pi. Let's see how that turns out. Ooh, that's even a possible answer. I was pretty confident I made a mistake somewhere along the line there. So the answer for this guy then would be 45 over 4 times square root of 13 pi. That's how we do this one. Not too bad. Backtrack, look what we did real quick. We had 2 pi r delta L, plug in the appropriate values, get something kind of like an arc length formula, and algebra and success. So not too bad. We got this problem. See you on the next one.